Azure Remote Rendering is an Azure mixed reality service that's available to everyone, and it enables extremely high detail, high fidelity geometry on limited hardware because it renders in Azure and then it streams it down to endpoint devices like HoloLens or desktop. So this means you can get around the limitations of the processing power on small form factor devices. Really, it's a service that provides an extremely easy way to leverage the powerful GPUs in the cloud so that you can render anything you need to render. And we support up to 2.5 billion points on point cloud models and over 1 billion polygons for meshes if you're using the premium version. And so this opens up a lot of key mixed reality use cases like collaborative design, layout review, on devices that might not otherwise have had the strength to do all of that.
Hello everyone, and a special welcome to James, who's going to talk about thinking holograms, augmenting AR with AI. And without further ado, James, please take it away.
Thanks, Martin. So what I want to talk about today is, and there are lots of other presentations on it, I'm just doing a slightly different thing, giving the business case rather than the tech case for combining AI with AR, and just trying to narrow down how AI would best be used for AR and fitting it into a larger context of the current climate for AR. So I think there's at least one other talk this year by Roland about creating AI avatars. And then that's Roland Smink. In past years, there have been a few also that have been more technical. But the way I want to talk about AI and AR is first to set up the proposition that when we're working with future tech, we're always dealing with it as a kind of historical research. And I'll explain that in a bit. Then I want to talk about the killer app problem. Then I'm going to propose that AI is the killer app for AR. I'm going to take a specific use case that I really like and try to decompose what the problems in implementing it are. And then finally, I'll introduce some workarounds that I've been doing with a company I've worked with in order to try to implement these sorts of solutions with AI and AR to solve real-world problems. So first, future tech as historical research. One of the things that happens when we talk about future tech is it's different than things that are more standard, like, say, working in automobiles or working in the hospitality sector, where we don't expect sudden changes. We expect things to sort of go along as they have been going. So while there's always changes, there's history, there's responses to economics. The problems tend to be well known, and the solutions are usually ready at hand. The thing with future tech is when we talk about future tech, let's say like cryptocurrency or blockchains or something like that, we're always trying to fit it into a bigger historical narrative and try to figure out how does this change our world drastically, right? So the mindset with future tech is always massive changes, drastic changes where we don't know what comes next. And at the same time, we don't even know if it'll take off. So this has been an aspect of the hype cycles that we've dealt with in future tech also, where things that look like they're super promising, later on we start thinking maybe it's not super promising. Maybe, we just got caught in a hype cycle that we couldn't control. And we end up, going down. And that's happened with, say, speech recognition over the years. It was big in the 70s, made a resurgence in the 80s, made a resurgence in the 90s. Every 10 years it comes along until we finally end up with the Siri devices that we have today, which are fantastic. And now it's a real thing. We're through with the hype cycle. So again, with future tech, we never know if we're just in a hype cycle or if we're on the verge of something great. And in order to analyze it, we always make some sort of appeal to a historical narrative and even rules of history that we're trying to follow. So here's the first way we tend to deal with AR these days for people who are big boosters, for people who work in it. I think we all just sort of assume AR is inevitable, right? We don't know how long it's going to take. Maybe it's going to take 2 more years, maybe 3 more years to get over some hardware hurdles. Maybe it'll take 10 years or 15 years even. But pretty much people are into this space don't doubt that we're eventually going to get there. We just don't know how long it's going to take. So there's this kind of historical narrative of the inevitability of certain things. And kind of the case that's usually made in pitches and businesses and so on is that AR piggybacks on smartphones. Smartphones were a huge innovation that changed the world. But here's the simple idea. Wouldn't it be better to do everything we do on our smartphones on glasses that we actually wear? And that way we have our hands free. That way we're always looking up and everything's a lot more safe that way. And people make eye contact. So the thesis is AR, whenever we get the hardware right, is just going to be like smartphones, but much, much better. And of course, there's always problems with this inevitability sort of argument in history. Things like the myth of the general strike, where we end up waiting for certain things to happen because we think they're inevitable and so obvious. And as conditions change, we're not quite ready to change with it because we've already put our stake in the ground and we forget that certain things may not be inevitable. So there's a great case of something called the original critical theory, the Frankfurt School in Germany, which rose there in the 20s and 30s. Basically, the problem they're trying to solve is an economic one, which is everybody in Germany for 10 years had assumed that, just like in Russia, a great revolution was going to happen and the proletariat would take over. And it just never happened. And so the second phase of analysis was, because people put their stake on the ground, the problem was, why didn't this the great proletarian revolution happen? And that's how people seriously thought of it in those days. Like the first proposition that it would happen was obvious. And so what had to be explained was not why do people believe in this, but instead what's preventing it, what's changed in the ground. And so there's inherent risk in putting our stake in the ground like that. We have to find better ways of explaining this historical problem and the, where we think AR fits into the history of technology. So here's another way that people talk about new tech when they're trying to put it in context, and that's the problem of the killer app. And the idea of the killer app, probably the best invocation of the thesis is simply that in order for a platform or a piece of hardware or a new tech sector to take off, you have to have some killer app that people find absolutely essential. Things that people didn't know they needed before, once the app is created, they realize that it solves all their problems. And the really great case of that was with the Apple II and personal computers. Personal computers are expensive. Back in '77, they ran for $1,300, which is almost $6,000 in our money. Or Wikipedia says that's how much it would be worth in 2021. With inflation in 2022, that's what, almost $8,000 now. So that's a lot of money for a piece of hardware. Nobody really wanted to invest in it because it wasn't clear what you could really do with it. You plug in a cassette recorder and you maybe play games, right? But you couldn't even really play games. Instead, you'd buy a magazine with code in it and you'd copy out the code by hand into your computer so that you could play a game. So if you're a hobbyist, that's something you're really into. But for most people, it didn't make sense. Instead, the whole world was run around the notion of having mainframes until this killer app came along. So I don't know who out there recognizes this. It's VisiCalc. It's the first spreadsheet application. And this basically changed the world beneath our feet, because with this, it made doing actuarial work and accounting work much easier. And because of that, it became an essential piece of software for almost every business. And because the software is essential, the hardware it ran on also became essential. And this led to the rise of the PC. PC had its own spreadsheet programs on there, Lotus and later Excel. And so we can say, basically, without this application, we would not be working as developers the way we do today. So that's basically the paradigm for all killer apps. So let's take another example. What was the killer app for the iPhone? Was it this? Was it this? Was it this? Or was it the store itself? And this is a tack that many people take. What made the iPhone really successful was a store that third-party developers could publish games and apps to. And the first reason is people got phones, didn't know what to do with them. They're just cool. And their phones are inherently short attention span devices. So people need to do something that's sort of fidgety and that appeals to short attention spans. And games are perfect for that. But because the games are short, what people are also looking for is free stuff. And the iTunes store provided all of that, provided lots and lots of free stuff. And then once certain things became popular, they could be monetized. And so those really successful first games like Angry Birds, sort of became really successful. But of course, Apple didn't have anything to do with that. What they did have to do with was putting out this iTunes store and creating a monetization program around it, found ways to incentivize developers to create more and more things, so that after a while, quality was important, but quantity became really, really important. Having lots and lots of things in your iTunes store, constantly new apps and games showing up, was essential to the success of the iPhone. I don't know if you remember what Steve Jobs said when somebody asked him early on what the killer app for the iPhone was. He said it was that it made calls, and it turns out probably not. The killer app was just apps in general. So let's take another case now. What's the killer app for the metaverse? So the metaverse is a kind of crazy thing, and I'm going to read this article, or part of an article that Charlie Warzel of the Galaxy Brain, which is a newsletter published by The Atlantic magazine, I believe. And this was just a few weeks ago. And he said, perhaps one day we'll all be trapped like legless rats in the infinite office of Meta's Horizon Worlds and toiling in a parade of conference calls under stultifying virtual halogen lights. But for now, while I can still drag my flesh prison through the analog hallways of our meat space, I am basking in the schadenfreude of Facebook's metaverse stumbles. And this came out after some internal memos at Facebook pointed out that even internally, people weren't really using it. We're having a hard time using Horizon Worlds. And then finally, to top it all off, a letter telling people that they really needed to start using it and enjoying it, or else. So that was fun for a while. It was a good bit of technology gossip. But it does kind of point out another underlying problem that, let's say that Horizon Worlds make sense in a certain way, right? If you've already accepted or decided that the metaverse is inevitable, then your question is, how do you get to the metaverse? What's your company's path to get there? And people inside of Facebook/Meta decided that office meetings were a great way to do it. And clearly, after the pandemic, having virtual office meetings seemed like an interesting use case. But unfortunately, the pandemic has gone away. So the vitalness of it, the imperative of it, has sort of lessened a bit. And so with Horizon Worlds, it does make sense. It's a little bit sticky. It seems like a kitchen table problem the way the Excel sheet was, right? People have to meet. People want to work remotely. This seems like it would be a really great solution to put out there to introduce people into the metaverse, and they could just sort of build out from there. But there's also just some inherent problems with it, which is we're missing the fact that people don't actually like meetings. People don't like being online in that way. You know what people do like, though? What makes intuitive sense to everybody? It's this silly thing that came out a couple months ago called DALL-E. And it's this notion that AI can let you just start generating these crazy images. And so out in the periphery, there's people, having conversations about whether this takes jobs away from creatives and all of that. But I think that's beside the point. The really interesting thing, that's a weird one. The really interesting thing is that children and adults could go to DALL-E once they got invited to it. And it just made intuitive sense to everybody. They could figure out how to start entering keywords to create images, and they would share them with each other. And it really took off because it hit a good chord. And so one way of looking at it is Horizon Worlds makes a certain kitchen table sense, right? It's solving a problem that actually is out there. It's just not clear that it's a really big problem, and it doesn't really capture your imagination. But something like DALL-E did. And ultimately, I would say what we really want out of a killer app is a combination of these two, something that solves everyday problems, but also, I feel horrible saying it because it's an overused term, but it has to be something that delights people a little bit. It has to be something they just don't get tired of. So here's the big question then. Having gone over all these cases of killer apps in different areas, what is the killer app for AR? Okay.
I know what that feels like.
Yeah, that's the navigation computer.
I see the diagnostic port. You'll have to cable in and see if you can access reactor controls or a nav log.
Copy that.
Okay, so that's a clip from a show called The Expanse. It's a science fiction show of the near future. And what I love about that clip especially is it's using a lot of special effects to tell what's ultimately kind of a dull story. They're just walking this guy through a procedure that he's working on. So you can imagine it as something like an airplane mechanic getting visual cues to finish his job, putting on a bolt or something, or a construction worker being sent to a certain area and being shown the nails he has to hammer in, and that counts it along the way. It's a pretty primitive problem all around. But that's also what kind of makes it cool, that we're using extremely advanced technology, some form of AI, to simply assist people a little bit with something they could probably accomplish other ways. This just makes it a little easier and makes it a little bit more accurate. And I think that's the kind of problem that AR really needs to solve in order to have a killer app. So based on that video, I want to decompose the problem just a little bit. And the first thing to be said about it is that we don't want to overcomplicate it. So a lot of people are really into the idea that AR can provide us with personal assistants or even personal friends in AR with their own AI intelligence that can accompany us in the AR world. I'm not saying that that's not a great thing. It would be very cool, but I don't think that's the killer app. I think that's something that will come out of the killer app down the road. So we're not really looking for a full concierge service or something like an AR Clippy, right? It's something simpler, just cognitive augmentation, something that nudges you when you're trying to accomplish everyday tasks. So we've said the problem is going to be small, but even figuring out how to solve something small like this with AR and AI can be really, really tricky. So here's the first thing out of the clip. We need some sort of object detection recognition. So in that clip, the astronaut was able to look at this little piece that he's engineering with, and it gets identified by whatever onboard HUD AI he has and draws this visualization explaining that it's a connection port. A second thing we're going to need on top of that is some sort of rules engine behind the scene that knows through context what he needs to do. Once the port is identified, it knows that he needs to find a screw and put the screwdriver into this hole here and turn the screw in. So again, it's a simple problem that can be really, really difficult to solve. There's a lot of complex AI happening already. But here's one more thing. One of the things we saw in the visualization is the object that gets highlighted to draw the user's attention has this perfect sort of mesh around it. And that's hard to do, actually. That requires some sort of 3D cameras or really advanced picture analysis. From that, we need to get some sort of plane detection to get the smooth sides. We need contour detection to figure out where the corners are. And assuming that we connect this with the shape of the real object that we have set up in a database somewhere, we also need pose detection to figure out how is that object oriented with respect to us and how far away is it. Again, these are problems that people are working on today. There are algorithms for it, but they're far from perfect and they're tricky. And ultimately, in order to make this sort of augmented AI work well, we need to cover lots and lots of objects. You ultimately would need some sort of universal library of objects that can be accessed in order to be used in these AI-enhanced AR apps. Okay, so I want to talk a little more about where I started getting really fascinated with this. And it started off with just being interested in AI in general to the point of finally picking out that particular use case that I just showed you as being kind of the essential thing that has to be solved for AR to make it awesome. And I think this was back in 2016 or 2017. I was thinking about the Terminator 2 and realized, well, I could probably do this in the HoloLens. At least the first part would be getting the visuals right. And then there's this outline detection on the image. And then there's object recognition too. And about the time I was working on this, Microsoft had a cognitive services team that was providing free web services in order to do AI stuff where you could send up an image and get back data. And you could do this fairly frequently, say every second or 2 seconds or something, which was enough to create this sort of prototype Terminator vision experience. And I think I spent probably 75% of my time just trying to get the look right, freeze framing, certain scenes in the Terminator movies, and trying to figure out what the HUD was going to look like. And then the rest of the time was actually just seeing what cognitive services offered at that point. And then using the cognitive services to provide textual data on the screen. So at that point, they had a primitive face detection where with some degree of certainty, it could detect male and female faces and kind of set an age. It had object detection of common objects and images, mostly taken off the internet. So I was able to identify objects like the wall, furniture, table, cabinet, desk, stuff like that. It had translation service and OCR service also. So I was able to take a picture of a book, send it up to kind of services and get the text back and get a translation if I wanted it. And you can see here it's identifying a person holding in hand. And then using the same tools, I could go outside and identify trees, ground, forest, conifer, wooded, dirt. So this was very much a first stab at it, but it really showed to me that the technology was more or less there. It's not all the way there, but we have enough to start working with the pieces and trying to figure out how they would fit together. So here's one thing a lot of people run into when they're trying to use AI with the HoloLens, say, or just with headsets in general, which is these headsets tend to use all of their processing power to do things like the SLAM algorithm and to analyze plane surfaces around, and a lot of things that just get the core functionality of AR headsets to work. And so you don't have that much extra power to do compute. So while it's possible to use machine learning on a headset like this, especially some of the stuff that Microsoft's been providing, it tends to run very slowly. Like you would get processing at once every 30 to 60 frames or something, which is decent, but it's also using up almost all the power that you've got on the device. So another way that it can be done is simply taking your images off of the screen and pushing them up to the cloud and using some servers in the cloud in order to process everything that's happening. And that works, but then you start introducing lag times or have uncertainty about how long it takes to get this recognition back. And with the use case we really want to do, I think you need to have it happening very, very fast. So here's a way of getting around that. And this is something I was doing with a company I've been working with called LabLight AR. You should definitely check them out. They're doing fantastic things in the biomedical and biopharma field. And the way we worked things out there was we would offload all of the compute and the processing on another machine. Just have say an i5 computer with a decent graphics card sitting by. And what we do is set up a camera with that and use it to do all of the machine learning processing. And it could do it fairly quickly, which was great. And then what we do is set up a server. And I don't know if you remember from 2016, 2017, but Microsoft released some tools for shared services where you'd send messages back and forth between the HoloLens and a server and possibly another HoloLens or a camera or something like that. So kind of use the same idea here. Whenever something is recognized by the server will send messages over a shared service, say over TCP/IP to the HoloLens itself. And the HoloLens would translate that into recognition and overlays in front of the field of vision of the user. And the final piece is just, and this is an old technique using sort of in clever ways, using Aruku or Charuku codes to sync up the placement between the HoloLens and the sensor itself. And once all the different vision devices know where they are in the room with respect to each other, it becomes really easy to do transforms of anything that's detected on one device and have it appear correctly on another device. So that's the basic idea. If the device you have at the time isn't sufficient to do the processing you need, you can always have another machine do it and just have a very short loop of communication between the two machines. And in this case, the purpose was simply to identify laboratory equipment and with the rules engine guide a user through laboratory protocols, which is something that's extremely vital. It's how we make vaccines these days. People actually have to stand there and manually do these processes because we're not quite at the point where robots can do it for us. So this is a fantastic use of augmenting AR with AI in order to accomplish not only everyday problems, but extremely valuable problems. And this is just a promotional video from LabLight AR showing what they do. So that gets us to the end of what I wanted to say about AI and AR. I hope it was useful to you. And in summary, the two main points are that AR really needs a killer app, and we need to be figuring out and talking about it. And secondarily, that I think AI plus AR is that killer mix that will put over the top and allow it to be used more generally and make it more appealing to people. Thank you for your time. I can take questions if anybody has some.
Hey, thank you very much. And when you're saying that we need the killer app, how long do you think it's till we will have that out there? Do you have any estimation for that?
No, I don't have any estimation. Part of it is we're working through. We have all this fantastic hardware, but it can still be better. It needs to be better, right? Because we have ridiculous expectations of what we want from AR ultimately. So, I mean, we want light glasses that have, 270 degrees field of view or whatever, perfect recognition all the time in AI. And for anybody who's been working in AI, you can't really get that. Anybody who's working in AR, we know there are just basic, even physics limitations at this point. We even need basic things like longer battery life, right? With lighter batteries in order to get to the point that we need to be. So it's a science problem, it's a technology problem. We don't know when it will be solved. But in the meantime, we have all these opportunities to figure out the solutions that will be ready when the hardware is ready, right? And that's, I think, that's kind of a great thing that we can continue our work now on the software side, on the business and design side, while other people solve the hard problems of the hardware.
And what do you see as the next step that we can reach? Like, will it be on the hardware side, or will there be any kind of software developments or paradigms that are figured out? Like, and who's working on that? Where will we probably see the next iteration where you'd say, okay, this goes in the right direction?
I think I see it in a lot of places. The best stuff is people who are doing prototyping, and it doesn't even have to be on high-end hardware, right? Or was it the Snap glasses? There were some really fantastic videos. There are concept videos primarily that showed what we could do with these sorts of devices. I forget, I should know her name. I feel bad not knowing it, but there's this great example of doing a kitchen app that would walk you through a cooking recipe. That's just a brilliant idea. And just that kind of ideation we can obviously do right now, and people should be. And the other big thing is figuring out a design language. We know with the web, it's taken them, was it 25 or 30 years to decide that flat design is cool, and that's what everybody should be doing. And we've only had about 6 years of really looking at AR design, right? So there's a lot of innovation that can happen there, and a lot of research that still has to be done to figure out how people will use these devices and interact with their world.
And is there already any kind of AR application where you'd say, hey, they have done a very specific thing really good, and you enjoy that already? Is there like any examples that you would like to share that that are out there? Like you showed, of course, one already with the medical.
Yeah.
But there's probably others as well, right?
So that one, I have a special place in my heart for it. But other ones I really like at this point are, let's say, are simple things. So, and this tends to be on the game side. We should be talking about enterprise more, but I think even games really reveal a lot. So there's a game called Demio, which is now on the MetaQuest Pro, and it uses pass-through VR so that you could put basically a D&D table style game on the table, and you still see the real world around that. So it's a digital image inside of an AR space. I think that's absolutely fantastic if they could get it to the point that two users could play with it at the same time. I think that's a very specific use case for board gaming that could lead to other very exciting things. I think probably a better collaboration story than a lot of the online VR meeting spaces that we are working with now. And Tilt 5 is working with similar technology, and I think they've sort of have bucked the trend and are concentrating on tabletop games also. And that's really cool, because if we start with games, we can discover use cases and interactions that we like, and then port those over to enterprise problems that we might have somewhere. I'll give you a simple example. If you can do a board game, then you can do an architectural and construction app, right? Because it's just a small hop leap away from that. Or if you can do a kitchen recipe thing, then you can do instruction and guidance for even dangerous work, like let's say airport repair, car repair, and that one thing people keep wanting to push us into, the operating room, right? But first you have to prove that the technology works somewhere else before you push it into the operating theater.
And where would you go, or where are you online to see all the latest developments? Like, are there any specific places where you see that things are coming together, or is it just in all the places in different, like, is there any specific where you, oh yeah, there's like, is there a special conference or special websites that focus on specifically AR tech, and maybe even in collaboration with AI?
No, I wish. And I just got a message from Roland Smink. The app I was thinking of is by Lauren Casson, who did the recipe app for the Snap classes, and she's amazing. As far as where we find things, one of the things happening now is that all the AR stuff is sort of broken up and, if I can use the term, balkanized between different industries and different hardware, right? So if you've got people working on the Magic Leap, they don't really work on the HoloLens. There's some overlap, but people tend to take sides the way they do between PCs and Macs. And so that, and there's the enterprise people versus the gaming people. And then there's people like Lauren Casson, who's very much an innovator and a creative. And it would be great if all these different pieces of the AR story would come together somewhere, but we're not really there yet.
So there has been the comment that we just that you just mentioned about the augmented baking. Then we have another comment where BB he agrees with you. Augmenting real-world objects with instructions, help, tutorials, etc. is the killer app for AR next to remote assistance. And we have a question from that person. What are the missing Lego pieces to make this a reality?
We're really close. So one of the things happening now is we're in this rapid fire phase of AI where new training models are being created all the time, new ways of training objects, and new problems are being solved with computer vision using machine learning. That it's really hard to keep up, right? So when I was working with the machine learning people in Belgium, one of the problems we kept having is everything would be open source, but pretty much 3 months after something was pushed out there, all of the software around it and the Python tools would change so that anything older than 6 months no longer worked. Anything older than 3 months probably would not work. And so it's hard, really, really hard to keep up with everything and also keep up with all the articles. So I'm presenting as a bad thing, but it's also a really good thing, right? It means we get things like DALL-E out of nowhere and we're not even expecting it. And I think that's going to happen over and over again. And remember, one of the great things about DALL-E is a major company came out with it, and then you suddenly had independent developers coming up with their own solutions that were as good or better almost immediately. So there's just something really amazing and fruitful happening in AI now, and we just have to keep our eyes open for it and figure out what tools we can pull into AR to accomplish our vision.
And if people want to get in touch with you, is there any place that they should go, or like is there LinkedIn, or how would they get
find me? So I'm trying to shed all my social media at this point. I'm mostly off of Twitter. I've been off Facebook for 2 years. But yeah, LinkedIn, I'm still there because I do have to do work, and that's probably the best place to find me.
All right, cool. So thank you very much for all this insight, and see you around on the conference here.
See you later, Martin. Thanks for your time.
Take care.
Bye-bye.
Bye.